Hi everybody, welcome to the fifth day of Code Vita coding. And right, so first, on behalf of FindMind, Innovative, and with you, let me welcome you for the session. It's just going to be called a Super ASCII string. The entire purpose of picking up all the problem statements for today is because most of them, the comments what I have been receiving, the messages what I have been receiving is about, I can see some sort of a panic about Code Vita. Hey, you need to understand Code Vita is a sieve. Okay, it is not a dangerous animal. It is a set of problem statements which you would find that TCS presents to us, and we need to solve. And look at the way they have done it: 6 hours, six problem, and open. You can talk to your friends. You can use any of your help. But when you meet them in an interview, they would be ensuring that you are good at whatever you have said that you are good. Okay, if for example, if there was a problem which has been solved by you, which talks about a two-dimensional array and matrix, jolly well be good in that. After solving the problem, and when you go and meet them, and if you feel they are not confident, you're not confident about a 2D matrix, then that is supposed to be bothered. Otherwise, absolutely relax. So let us just take this problem and quickly solve it. So what is this super ASCII string all about? A plain vanilla problem. Okay, this is what it is. In the byteland country, a string S is set to be super ASCII string if and only if count of each character in that string is equal to its ASCII value. Okay, but don't bother ASCII value. What we see in the normal standard is, for example, for mean capital A to capital Z, it is 65 to 90, and for small a to small z, it is 97 to 123. Fine. But don't bother, you're not going to have so many characters. In the byteland country, ASCII code of A is 1, B is 2, Z is 26. Okay, so it's going to be a very simple problem. All you need to do is walk on the string. And you need to count every single character's occurrence. That is all. Okay. So let us just have a look at number of test cases 100 and string is around 400. Look at the constraints. And they have clearly said the string will contain only lowercase alphabets, small a to small z. So that much you would find that is going to be very helpful. For each test case, we just have to say yes or a no. So two, for example, there are two test cases. BBA is yes and SCCA is no. Explanation, very simple. The count of character B is 2. You can see here they have kind of given the given you the algorithm. Count the character and store it. And find out, check whether they are exactly the same. Otherwise, yes or no. That's all. Okay. Now, when we start programming, should you go through the entire string? Now that you can see here, little optimization can be done. We might not have to go through the entire string. Why? Because, shall we? File save as, okay, sa.c. Okay. Yes, replace it. Paka. So why should it? Why is it that you need not go through the entire string? Because even when I am adding, I can do a small validation. For example, if I am adding e, if it is 0, I can add 1. If it is 1, I can add 1, which is nothing wrong. Even if it is 4, I can add 1. If it is already 5, adding 6 means automatically it is going to say you are a disqualifier, right? You are supposed to be there only 5 times. You are there 6 times. So like a simple one if should solve the problem for your optimization. I don't think anything else is sufficient. Okay. And kindly do not call this as a hash table. You want to call, fine, you can call hash table. But you would find that hash table has got a respect and we need to give that respect. Fine, let's not call everything as hash table. Okay, and there's it 400. So 401 is equal to, okay. I have some test values. Sorry, I have some test values which we have created. So maybe we can use one of them. Yeah, it's here. Just you can use one of them, and we can test. I just have only few. Maybe if required, we can generate more. So that's string value, and we need to have a an array. What is he going to have? He is going to have occurrence of the characters. Occurrence of the character. Okay, and how many? We need 27. Why 27? Actually 26 is sufficient. If you number them from 0 to 25, we need to adjust that window every time. Instead, if you have 27, don't touch 0, use 1 to 26. Pakka? Good. Fine. And to touch this, we'll have one occurrence character. Okay, just have an IND. Sufficient. And for string, let us have one more IND. str IND. Cool. So let us walk on the entire string. Walk on the entire string. For str IND starts with 0. What's the condition? Str of str IND should not be null, not equal to null. And what is the alteration? Alteration is strind plus plus. Now, what is the process you do with the character? Just check, be a bit careful. Look how it is being calculated now. Okay, if occurrence char of, remember the character itself can be used to help an index for us. For example, E is the first character. So str of strind. Okay, E is the first character. Okay, if I subtract 96 from this, he will give me the exact value. Let's look at it. 97 is cap small a. So 97 minus 96 becomes 1. 98 is B. So E is A, B, C, D, E. 96, 97, 98, 99, 100 and 101. 101 minus 96 becomes 5 into box number 5. Okay. If that is less than the value there. Why? Because if there is 5 already, adding one more is going to give me a negative result. So less than str of strind minus 96. Then you need to add it. Okay, I can say here occurrence char of strind minus 96. Okay, minus 96 has got to be inside the square bracket. Okay, so this value minus this, so minus 96 plus plus. So if that has got to become 0, jolly well have one small loop and ensure everything is made into 0. You may be wondering, why can't we just put a 0 over there, occurrence char 27 equal to 0. First time that will happen, buddy. Subsequently, remember, test cases are going to be there. So you need to find that every time that has got to be done. So let us just have occurrence, IND less than 27. IND less than 27 and IND plus plus. And just make occurrence char of IND equal to 0. So this does the complete refresh. Everybody becomes 0. That's all. Over. Code over. So now decision making time, because we need to print the output, right? Whether it's out is yes or no. So now this case, let's have a space because it's going to go in a loop. So why would I come to line number 70? There are two options, because line number 12 threw me out, or this guy threw me out. Why? Because it was not less than. It means either it is becoming equal. This means don't stand there, get out. You are actually, that string cannot be a super ASCII. So first, why did you come out? If you come out because of the break, if you come out because of the break, it means you would find that he would still not be equal to null. In that case, you can just say here, no. Printf, no, because you have been thrown out of the loop. Okay, else. It was not, you were not thrown out of the loop because you completed all the characters. Now I need to walk on the entire array for IND equal to 1 onwards. IND less than or equal to 27. 27 IND plus plus. Now check what should be equal. First, it has the right to be 0. Understand that first of all. Occurrence of char of IND definitely can be 0 because that character never came into picture. Or occurrence of char of IND is equal to IND. A has got 1, 2, B has got 2. In that case, continue. Get continue. Okay. So otherwise, else no. Continue. So when you come out of this, continue. Forget the condition is satisfied, continue. Otherwise, else you need to have a break. Else it's got to be a break. If this condition is not satisfied, don't be in the loop. Get out. So when you come out of this loop, we can just check over here. If IND became 27, IND less than or equal to, IND is greater than 27. Remember 27 I have 0 to 26. So 1 less than or equal to 26, gentlemen. So if IND is greater than 26, it means you walk to the entire array and all is well. If all is well, printf S. Printf S. If it isn't so, printf no. There was some sort of a trouble. Maybe it is less. It has all the right to be a less character. Else, let's say printf no. Cool. Perfect. Now let us just try this with single string. This single string, I have made it a point that it is equal, which means it is supposed to say yes. Let's try it out. It says no. Okay, let's find out. I mean, debugging is a very interesting thing. I always love debugging. So let's find out why is the no happening. There are two places where I am saying no. So let us test first of all. Is this the guy who is telling me no? First thing, is this the guy who is telling me no? No, he is not the one, which means my entire string is happening perfectly. So this guy is saying no. Let's find out. Let's find out. Why is he saying no? Okay. Now in this no, I'm going to print my IND number. Who was giving me trouble? Percentage D. Let me just give you what is my IND number. Let's have a look at it. Verification. 3. 3 means C. Do we have C here? No, we don't have C at all. In that case, why did he throw me out? C is there. Yes. C is there. You can see here. There are only 2 times. Okay. In that case, if I add one more, will that become all right? Check it out. Pakka. This is exactly how you debug, ladies and gentlemen. You have to just make your own method. Most important thing, never ever give up. Never ever give up. That's only one important factor. So let me just take one more string of mine. I hope that also I have made it perfect. This one, I think I have made it perfect. Let us just test that out. Okay, let's make this into a comment entry. So you know that this has been tested. Control V and check this out. No. Okay. I mean, honestly speaking, I do not know. Okay. Now let us just check it out. How many are there? Okay. We'll do one thing. We will make a string, and which is going to be yes. Okay. For example, Z is 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and 26. Let's have 5 E's inside. Okay. E is got to be 5. So 1 E here, 1 E here, 1 E here, 1 E here, and 1 K, 5 over. And let's just have O. O is supposed to be 10. Okay. A, B, C, D, E, F, G, H, I, J. No. K, L, M, N, O. 15 O. Okay. Let's just spread it. Okay. 1 here, 1 here, 1 here. How many do we have? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let us just try this out. Should he say yes? He should say yes. Good. It works. Okay. Let us just make some D. It works. If I say, for example, 1b, if I just put 1b somewhere here, for example, the end I'm having 1b. How many b are supposed to have? We need to have 2. No, it works. Okay, if I just add one more b, it works. If I add an a somewhere here, it should still work because a is supposed to be only 1. Work. Okay, now if I just have one c here, it is supposed to say no. Good. If I add one more c here, supposed to say no. If I add one more c somewhere over here, suppose say yes. That works. Now this has got to be put into a loop. Okay. Now, let me just show you all the code what have been done earlier. Okay, that has been there. This is a square free. This is square free. Okay. What did we do? Found all individual prime factors, counted it, nothing more. We just counted it. And after counting it, what did we do? Okay, remember there is a formula for sum of NCR. Sum of NCR is 2 to the power of n. Okay, I was told by my student that it is because of the proof by binomial theorem. As I said, okay, fine. I said I don't mind. I have learned it in the school, pakka. And so, how is it being done? 1 less than, okay, 1 left shift, prime factors counter, minus 1. Why minus 1? Because 1 is not on. And this we did today, okay. And divine devices, this we did today. Okay, and this is divine devices. Okay, how did we do this? Remember, we used pointers. This is also one single screen. We didn't do anything much. Okay, divine devices. This also we did a lot of optimization. How did we do? Okay, in fact, if you remember, we corrected it the next day. Okay, because when one of our students had this set. And then pattern. Okay, remember the trapezium pattern and the Rome solution. Okay, Roman number. Okay, let me just, I know if I leave it, you're going to take a photograph. I don't mind. I hope you have taken. Page down. Page down. Page down. Okay, and today's program. This is Christmas tree. Okay, most of students have, sir, could you please put it in one single page, sir? Yes, sir. Done, sir. Okay, one page. You mean, let's at least have that. No, yeah, let me make it a little bigger for you. Fine. And what we did now, ASCII. Cool, Paka. So I'll see you on Monday with one more problem where you would find that we are going to demonstrate how we discuss among ourselves and solve the problem. So there's going to be a live session for you in the sense you would know how we discuss and what are the points that is being covered. So that's going to be the one that is going to happen on Monday. So I'll see you on Monday, that is tomorrow. Okay. Fine. So on behalf of Fine Mind and Innovative and with you, okay, thank you very much for being here. Once again, be patient. Start working. Start working, right? And so I'll see you tomorrow at your respective timings. Thank you.